SyntaxMatrix presents AI Trending News.
This is pretty crazy. Open source AI is no longer a few months behind the closed frontier models. Today, we have a new open source model which is just as good. So Moonshot AI just released their latest model, Kimi K3. It's a massive open source model, and get this, it's right up there among the best closed models out there, including GPT 5.6 and Claude Fable. Like, this is ridiculously intelligent and performant. In this video, we're going to go over all the impressive things it can do, and of course I'm going to show you where and how to use it. Plus, we're going to go over its cost, specs, benchmarks, and performance against other AI models. Let's jump right in. First of all, it's important to note that all the top AI models can already do simple stuff like helping you summarize things, take notes, reply to emails, writing essays, etc. So instead, what we're going to test are some much harder prompts that require like multiple skills, workflows, tools. I'm going to test the hell out of it on much trickier prompts. Now, there are various places you can use Kimi K3. For example, you can just use it directly on their online chat interface. But if you use it this way, you're not really unlocking its full potential. That's because this is designed for multi-step, long horizon agentic workflows. So basically, tasks where it can autonomously use tools and keep doing stuff for multiple steps until it achieves your goal. So actually, a better way to use Kimi K3 and all the frontier models is to use it through an agentic harness. Now, you could link this to Claude Code or Codex, or what I like to use is their native harness called Kimi Code. And with this, you can basically use Kimi as an agent to work on multiple projects at once. And each project can contain multiple files and folders, as you can see here, which persist locally. And with this way, you can basically have an army of agents working on different projects at the same time. Now, currently you can use Kimi Code using the terminal, which looks like this, which I don't really like. So what I like to do is use it through an IDE like VS Code. So it's super easy to install. All you need to do is go to VS Code and then click on extensions. And then at the top here, type in Kimi, and you should see Kimi Code. So simply click on this and then click install over here. So afterwards, you should see this Kimi Code button. So once you click on that, you can open any folder. And then down here is where you can chat with Kimi Code. If this is too squashed for you, you can also expand the chat like this or click on this button to expand it to full width. Now down here is where you can select the latest K3 model. And then here is where you can select the thinking mode. And then you can also click on this button to enter plan mode. So this will just plan out its strategy and not execute anything. So that's basically how Kimi Code works. Let's start off with a really tricky prompt already. Let's get it to simulate liquid splashes with adjustable gravity and light settings. And to make this even more complicated, allow me to control movements using hand tracking via webcam. Put everything in a standalone HTML file. And the most important part is do not use Three.js or any external libraries. I want to test its physics understanding. Can it code up splash physics completely from scratch? Let's press run. Now, as one of the frontier models, this is quite slow. It worked for 30 minutes. First planned out how to carry out this task, then it's rendering this liquid splash playground. It knows to check whether that thing works, for example, by pulling up my Chrome browser and taking screenshots of the interface. And if it doesn't work, then it proceeds to troubleshoot and fix the issue until you get a fully working app. So it did identify some issues and it proceeded to fix it, and then it found a dramatic improvement. Then it's proceeding to verify the app one more time with a full test. And then afterwards, it gives me this final splash.html file. So that's pretty much it. Let's see what it built in just one prompt. Alright, so first you can see indeed we have this liquid splash simulator built completely from scratch. Let me decrease the gravity. And here's what we get if we decrease the gravity. It's now floating upwards because gravity is a negative value. Let's increase this to like a bit closer to 0. And then we can also play with viscosity. So here is really high viscosity. And then here is goo and cohesion. So if I increase it, it looks like this. Very nice. Here is surface detail. So it looks like this. I can even add rain here, so let's click on rain, and wow, that's pretty cool. Now I should be able to control this with my hand using webcam, so let's click on this hand button to turn on my webcam. And indeed, now I can use my hand to create these liquid splashes. And while I do that, let me also try to adjust the light angle, so it looks like this if I adjust the light angle. And then here is light intensity, which looks like this. Very nice. And then also glow. It's a very subtle effect. And then tint hue. So we can also change the color of the water. So anyways, there you go. Here is a fully functional liquid splash simulator with adjustable liquid settings like viscosity and cohesion, and also adjustable light settings, and everything just works. I can even control this with my hand movements, and it coded this up all from scratch without any external libraries. This is pretty crazy for an open source model. Now, as a frontier model, Kimi K3 is really slow. It seems to think for a long time and be extra careful, and so here are the details for this section. So it used over 2 million input tokens and 46k output tokens. Alright, next let's see if it can actually automatically help me build stuff in Blender, which, if you're not familiar with this, it's like a 3D modeling tool. So first of all, in Blender, I already installed and enabled this Blender MCP, so first I'm just going to click on Connect to MCP server so that it's running on a local URL, which in my case is 9876. And then back in Kimi Code, I'm going to write this. Use Blender MCP at this address, localhost 9876, to make me a realistic animated V8 engine. Let's press run, and it should automatically pull up Blender and start creating this V8 engine in 3D. Alright, so this was a really hard task, so it took it quite a long time, around 40 minutes, but it managed to get the job done. So it indeed pulled up Blender and it started just making stuff in my Blender interface, building the different components of the V8 engine, and then planning the cutaway, lighting, camera, etc, etc. And then after a ton of thinking and building, here's what we got. Indeed, it was able to make a fully animated V8 engine in Blender. In fact, let me play this so you can see this V8 engine in action. How crazy is that? Like, it was actually able to animate everything, including the pistons, and everything just looks beautiful. And I mean, if you expand what it did, it built a ton of different components, as you can see from this list. This was incredibly complicated, but it was able to build all of this in just one prompt. How ridiculous is that? Like, if I click on each of these things, these are all separate components. The amount of details that it coded up is just absolutely insane. And then for your reference, here is the final render. Now this took a lot of time and work. Like I said, it took around 40 minutes, and as you can see here, it took around 17 million input tokens and 152k output tokens. It's definitely slow, it thinks and plans for a long time, but it gets the job done. So very similar to the vibes that I got from Claude Fable and GPT 5.6 Soul. Alright, now Kimi K3 is incredibly good at using multiple tools and platforms and doing really long agentic workflows. So here's a really complicated prompt to test this out. From the most recent NVIDIA quarter financial report, I didn't even give it the link to anything. It needs to search and find the report itself. Create a video summarizing its financials and future outlook. Include a voiceover using Gemini TTS. Use hyperframes to create the animation. I linked it to the GitHub repo, and if you're not familiar, hyperframes is basically an open source tool for you to code and create animations. It should be 16:9, around a minute long, include charts, graphs, and other visuals. Use this MP3 as the background audio, and then reduce the volume so the voiceover can be heard clearly. And then afterwards, I also pasted in some documentation on how to actually use Gemini TTS. And afterwards, I also gave it my API key so it can actually generate the voice. And that's pretty much it. Alright, so it thought for a really long time it had to download the latest NVIDIA earnings release, plus also look at how to download hyperframes. It also had to plan out everything and then generate the voiceover using Gemini TTS. But afterwards, in just one prompt, it finished and gave me this result. So let's open this up.
NVIDIA just posted a record quarter, $81.6 billion in revenue, up 85% from a year ago. Revenue has climbed 8 straight quarters, from 44 billion to nearly 82, and the growth rate is re-accelerating, not slowing. The engine is the data center, $75.2 billion, up 92%. Within it, networking revenue nearly tripled. Beyond the data center, edge computing, gaming, robotics, automotive added $6.4 billion, up 29%. Profitability is just as striking. Gross margin recovered to 75%, and adjusted earnings per share of $1.87 are up 140%. The cash machine is real. Nearly $49 billion in free cash flow. $20 billion went back to shareholders, with $80 billion more in buybacks authorized. And the outlook? Next quarter's guidance is $91 billion, above Wall Street expectations, and it assumes zero data center compute sales to China. The takeaway? A record quarter. Demand still accelerating, and NVIDIA says the AI build-out is just getting started.
This is pretty much perfect, absolutely beautiful. So you can plug in any document and get Kimi K3 to not only just generate some presentation slides, but even a full presentation video with voiceover and animated graphs and other visuals. Very, very impressive. And if I click on this section, note that this took a really long time. It did burn a ton of tokens, so 16 million input tokens and 256k output tokens. Alright, next let's test its ability to generate 3D models and animations. So I'm going to write this. Create a beautiful 3D animated model of a grand piano, include a slider to show a smooth transition from a fully assembled piano into an exploded view, which shows the inner workings, such as the strings, hammers, dampers, etc., etc. Allow pressing keys on the piano to actually play the correct notes. Use a single HTML file. Let's press run. Alright, here's what we got. So it, again, thought for a long time, but eventually it did give me a fully functional 3D render of a grand piano with the full 88 keys. And everything worked. The exploded view works. I could also click the notes to play it, and glissando also works, so like just clicking and dragging across the keys, as I'll show you in a second. And the really cool thing is it even added a demo button that could play the Fur Elise. Now it did give me one error, which is that the lid was not in the right place. It was just flopping on the ground instead of being propped up by the stick, so that's what I put. And after just one more follow-up prompt, it fixed the issue. So here's what the final render looks like. Would you look at that? This is absolutely beautiful, and let me just slide across the keys. The keys work very well, and if I zoom in on, the inner workings of this and then play the piano, notice that everything is animated properly, including the hammers, the dampers, and the strings. Now the really cool thing is, like I said, there's a demo button for me to play the Fur Elise. So let's click on this demo and hear what it sounds like. How cool is that? And then finally, let's also explode this. So if I press on explode, it does explode the piano into these separate sections. In fact, I can even drag the slider so you can see what this looks like. Very cool. So in just 2 prompts, it was able to generate a fully working grand piano that can be played, and it even generated a Fur Elise demo. Really impressive. Now let me open this session for you. So this was actually pretty light. It only used around 400 input tokens and 5,000 output tokens. Alright, next let's see how good it is at coding up a shooter game. Create a 3D game using Three.js. It should be a futuristic battlefield where I control a mecha warrior and shoot down waves of alien creatures attacking from the sky and ground. Third-person shooter perspective, use publicly available 3D assets. This is the part that trips up most other frontier AI models. They're not actually able to import 3D assets into my game for some reason. Make it look amazing like a pro AAA video game. Alright, so it first enters plan mode, and then it plans out how to code up this game, and then afterwards, after a ton of thinking and coding, it finishes the game. And the nice thing is, it also pulls up the browser to take screenshots to check that everything works. For example, here it's actually inspecting the frame and verifying that everything works. And then here it's also verifying that the mecha runs and the jet glows, the muzzle flashes, combat looks right. And then finally, it is done. So let me spin up the game. Alright, so it says I use these keys to move, I use my mouse to aim, I can use this for Fire Plasma Canyon, space for jump jets, shift for dash. Let's press deploy. Alright, here we go, and I already see some enemies in the sky, and this actually looks like a mecha warrior. This looks way better than what I got from Claude Fable or the open source JLM 5.2. And it was able to code all of this in just one prompt. I could probably add further follow-up prompts to make it look even better, or add more options or features. Now again, this took quite a long time to actually code up everything. You needed to search for existing 3D models to use, you needed to plan out all the game dynamics, and this took roughly 12 million input tokens and 135k output tokens. Alright, next let's see how good Kimi is at making music. I have high expectations for this because the team is quite musically inclined. In fact, throughout their designs and even the names of their paid plans, there's a lot of musical influence. So hopefully this Kimi K3 is also good at making music. So for my prompt, I'm gonna get it to make a DAW interface with these instruments: piano, synth pluck, strings, drums, and bass. For each instrument there should be a piano roll where I can drag and draw notes on the timeline. By default, show a powerful, expressive 32-bar song rich in complexity that would win a Grammy. Include effects, automation, panning, and make sure everything is mastered well. Alright, here's what I got, and in just one prompt it was able to code up a nice song already, but it's kind of lacking in detail and complexity, so I wrote, add more variation and creativity, you can add more instruments if necessary, add risers and drops, add volume and FX automation for the tracks, add more width, make it sound amazing. So afterwards it worked for a few more minutes, and here's our result. It's not like a professional song, it wouldn't win a Grammy, but it's pretty good for an AI that just coded this up from scratch. It didn't even use any virtual instruments or anything like that. Notice that it includes all the settings that I specified, including reverb and delay. It even added track automation down here. It even added effects like risers and crashes. Pretty good for just 2 prompts. Now let me also expand the session here so you can see how many tokens it used. This one took a bit longer, so it used like 1.5 million input tokens and 35k output tokens. Alright, now those were some examples of using Kimi in Kimi Code, so you can take advantage of its agentic capabilities. But of course, you can also just use it on their native online chat platform. So I'm going to show you some examples of it here. Simply go to kimi.com, which I'll link to in the description below, and here's where you can chat with it. And it's a pretty simple chat interface, just like ChatGPT. So next, let's see if we can get it to identify cancer. I'm going to upload this image of 6 different scans. Each scan actually contains a type of tumor. I'm going to paste this into Kimi and then ask it identify the types of tumors in each of the 6 images, if any. Alright, so it thought for around 10 minutes. It autonomously ran some Python codes to zoom in on each panel individually, and even within each panel it zoomed in even more to really figure out, which specific areas contain tumors. And then afterwards, here is its answer. So number 1, it identified meningioma, which is actually correct. And then number 2, it said possibly leptomeningeal metastasis, which is wrong. Number 3, it also said meningioma, which is wrong. 4, no tumor, which is wrong. Number 5, craniopharyngioma, which is also wrong. And then number 6, it said no tumor, which is also wrong. So we got 1 out of 6 correct. Still better than the leading model out there, GPT 5.6, which got none of it correct. It just said there were no tumors. And also still better than Claude Fable, which just simply refuses to answer any biology or medical questions. So it's not perfect, you can't really get it to identify cancer via scans yet, but it did give me the best answer out of all the frontier models so far. Alright, next let's test its ability to do deep research. In fact, on this online web interface, you can select this deep research option with Kimi K3 Max. So let's try a really complicated medical example. Analyze the mechanisms of this propagation in Alzheimer's disease. Contrast monoclonal antibody therapies targeting each protein, etc., etc. Include relevant tables and visualizations. Let's press run. So it needs to search really deeply in the scientific literature and pull and synthesize relevant information, and also use tools to, plot out graphs and charts and tables and give me a really comprehensive report on this specific issue. Now, it's not like the other frontier models can't do this, so this is more of a test to show you its writing style, its deep research style, and its overall vibe. For example, GPT 5.6 tends to be very short and concise, whereas Gemini seems to be a lot more verbose. Alright, so this took a long time because I did enable the deep research option. It took around 20 minutes, but here is the full report. So it gives me first an executive summary, and then it talks about the mechanisms of amyloid beta propagation, which is what I specified in the prompt. It's jam-packed with information. Each piece of data does have the correct citation. And then afterwards, it gives me a nice flowchart showing how everything works. Afterwards, here are the mechanisms of tau propagation. Again, super thorough and jam-packed with information, all with the relevant citations. And then here is section 3. It gives me a nice concise table of all these antibodies. And then afterwards, here's another nice figure showing the results of all these trials. And then here's another table. I really like the thoroughness and the amount of detail that it outputs in this research report. It's really hard to objectively, quantify its performance, but at least for me, I do like its output a lot more than GPT 5.6 Sol, and especially Claude Fable, which won't even allow me to do any biomedical research. And then here's the next section, critical appraisal of phase 3 evidence, etc., etc. It gives me some really nice figures plotting everything out. Finally, it ends with synthesis and outlook. A super thorough deep research report with a ton of information. This would take a human several weeks to compile all this information and plot everything out, but Kimi K3 was able to do this in a matter of minutes. Alright, so those were some of my tests on Kimi K3. It was an absolute pleasure to use, and I hope you can feel the intelligence and performance here. Just from the initial vibe I got, this is definitely as good as GPT 5.6 or even Claude Fable, and definitely better than the previous Claude Opus 4.8. It's just so good at creating stuff and handling these really long horizon tasks. It knows how to check everything and verify with very few errors. Next, let's go over the specs and cost and performance. So first of all, this will be open source. They're going to release the model weights later this month, and this is a massive 2.8 trillion parameter model. It's built on their Kimi Delta Attention and Attention Residuals.
Now, something that you need to understand as well is how on earth did they do this? Because this isn't normal what Kimi has done. Kimi has, really shocked the world. We've seen the DeepSeek moment before that essentially broke the stock market, and that was super interesting. But Kimi K3 right here is essentially doing this again, but an even greater scale. Under the hood, how does this thing work? Okay, I'm basically going to explain to you this complex diagram in the simplest way possible. So essentially, Kimi K3 designed to use its computing power more efficiently. First, it uses mixture of expert system, and the model contains 896 different expert networks, but for each piece of information, it only activates 16 that are the most useful. So instead of using the entire model for every task, it routes the problem to the right specialist. It also includes 2 changes called Kimi Delta Attention and Attention Residuals, and these are meant to help important information move through the model's many layers, so details are less likely to get lost or weakened. The result, according to Kimi, is around a 2.5 time improvement in scaling efficiency compared with Kimi K2. And that doesn't mean that Kimi K3 is simply 2.5 times smarter. It means that as the company adds more compute and more training data, K3 is able to turn those resources into capability more efficiently than the previous model. So Kimi K3 essentially just has better information routing, so it can get more intelligence out of the same amount of compute. And Kimi K3 just 3-shotted this CSGO X Portal clone for me using around 600,000 tokens. $3.24 in API usage. Same token would cost $10 with Fable 5 and $6 with GPT 5.6. The era of free indie game development is closer than you think. And so essentially what he's showcasing here is just how incredible it is in terms of the model being able to code a video game. You're going to see a lot more examples of this, but this is something that is really true. You are able to do a lot when it comes to coding games with Kimi K3. Because the model is so good at, doing entire code bases, it's able to code functional games in often 1 or 2 shots. Of course, with 1 or 2 minor errors in some cases, but most games I've seen or played have been very, very effective. You can see they've got their own examples, which is this 3D open world. So Kimi K3 built a fully procedural browser-based 3D exploration game using 3JS, web GPU and GPU compute, and it procedurally generates the environment whilst using a 3D asset generation tool to create the rider and horse models, producing an expansive open world with forests, a log cabin village, snowy mountains, and dynamic weather. And they used some external assets such as an animated cowboy and horse models and terrain data, but nonetheless this is still something that is rather effective. We can also look at case 2, where Kimi K3 built a Game Boy Advance emulator by adapting a licensed 3D model, integrating a real MGBA WASM core, and enhancing both the interface and gameplay through recursive self-improvement. External assets were used, of course, special thanks to Nintendo, as they've said, but this is something that is just showing you just how good this model is when you're able to do these. And guys, by the way, you are actually able to play these. So I know a lot of times they will come out with demos that look super amazing and super impressive, and then when you try it, it just doesn't work the same way. I've tried all of these, and all of these are very, very effective. And we've got another case here, which is case 3, and where Kimi K3 built a browser-based game-based web swinging experience set in a cyberpunk megacity, converting and optimizing hundreds of Blender assets into real-time 3D worlds. And it designed realistic traversal mechanics using semi-implicit Euler pendulum swinging physics with energy-conserving rope constraints, and polished gameplay into smooth 120 FPS experience. They did use some, equipment to do this, but I actually played this game and honestly, it was pretty smooth. I do have to say that my gameplay wasn't as smooth as this. Maybe it's probably a skill issue on my part, but it was definitely very visually impressive and it didn't break at all. They also showcased a mechanical typewriter where the prompt was given a spec for a museum grade 1930s typewriter web app. Kimi K3 used 4 sub-agents to build a Vite/TypeScript/React/3JS app, and it delivered 242 individually animated parts and real exports. So this is something that wasn't just pretty, this was something that actually did work in terms of actually giving you the file that you actually wanted. So these are the kind of things that it was able to do. Not only was there that, there was this case 5 with a voxel art Colosseum. Kimi K3 built an interactive world with a voxel art Roman Colosseum with gladiator duels, animated crowds, wildlife, and physics-driven interactions. It iteratively self-improved the environment and gameplay through 20 rounds using headless Chrome screenshot inspection to detect and fix visual and gameplay issues. So once again, this is one of those cases where we're actually looking at just how good Kimi K3 is in terms of being able to iterate over a large code base. Remember, one of the key features of this model is that it's able to think for a long time. Now, there are some cases where people think this is a disadvantage, and I honestly have to agree because you don't want the model overthinking everything, but they basically show that this model is able to get a lot of, those difficult tasks done, which is something that you really do want to see for those models, because when it comes to the most ambitious projects, oftentimes this is where these open source models do tend to fail and break down. And so if those models hold up in those use cases, that is where things get very impressive. Now, we get another example here of the voxel art Colosseum. So this one is actually a 3D based fighting game on a custom web GPU engine featuring combo combat, AI opponents, cinematic cameras, and procedurally generated arenas, and it integrated open assets, engineered rendering and gameplay systems, and delivered a polished high performance experience. And it did use some external assets such as animations pack, but nonetheless this is still showing you what you can do when you have an AI system that is agentic enough to get the work done. They also were able to get a Wuxia style RPG. Kimi K3 built a browser-based 3D martial arts RPG featuring melee combat, quests, inventory, dynamic weather, and explorable interiors. It modeled the game environment in Blender with improved collisions and PBR texturing, integrated and adapted open assets, and designed the complete gameplay experience, and it used maybe 1 or 2 external assets. So this is something that I think is going to be super interesting for the world of game development, when you can simply code a game that is super specific to you, that you want in your style, in your look, in your fashion. That is going to open up an entire world of creativity that we never got to see before. Case 8 is here with a 4v4 FPS arena. It was able to build an arena featuring 8 weapons, AI teammates and opponents, destructible environments, and it procedurally generated the game's characters, weapons, environments, and visual effects, designing a complete multiplayer style gameplay experience. And this is super impressive if you know just how much that, really takes in terms of design. We also had it be able to recreate Interstellar's Gargantua. So this was really cool. Apparently this was where Kimi K3 was working via watching itself work from 62 screenshots, each one read, diagnosed and acted on. And so this was one of the most beautiful visualizations, and it just goes to show just how very effective Kimi K3 is. It had cinematic mode, post mode, all these different modes. You're able to visualize the beauty of Interstellar, and Kimi K3 actually excels at motion design, animation and video editing because its native multimodal architecture understands text, images and video all within the same model. They're not chaining things together, it's all within the same model. So in this example, what they show is a 3 blue 1 brown style motion graphics explainer of its own architecture, and it translates the technical ideas into animated diagrams and transition.
Now, like all of the frontier models out there, this is designed for long horizon coding, knowledge work, and reasoning tasks. And check out these benchmarks. This is absolutely crazy. So in terms of deep SWE, which is like currently the most accurate measure of how good an AI model is at software engineering tasks, you can see that Kimi K3 is edging really close to Fable 5 and GPT 5.6. And it's a massive lead compared with the previous Opus 4.8, as well as the next best open source model, GLM 4.2. This is over a 20-point lead, which is crazy. And then in terms of terminal bench, frontier SWE, program bench, and all these other agentic coding and software engineering benchmarks, again, you can see that Kimi K3 in some cases is even better than the best model out there, GPT 5.6 Sol, as well as Claude's best model, Fable 5. Absolutely ridiculous, especially since this is from an open source model. Same with like over the past few weeks, the US government kind of suspended access to the frontier models like GPT 5.6 and Fable over fears that it'll be too dangerous, but Kimi K3 just completely undermined everything. They released a model with the same intelligence, plus it's gonna be open weights so everyone can use it.
An open model on top. For 2 years, America told itself China was 6 to 12 months behind, that we would have time. That story died this week. Now, so who built this thing? The story that China just copies dies the moment you take a look at this founder. His name is Yang Zilin, 33, topped his class at Tsinghua University, this is China's MIT, finished a machine learning PhD at Carnegie Mellon in 4 years, interned at Google Brain and Meta, and he co-authored 2 of the papers that shaped how language models work before GP3 even existed. This isn't a guy just copying American AI. He was there in the beginning, he helped build the foundations, went home and built a rival, backed by Alibaba and Tencent at a valuation reportedly north of $30 billion. This is not just a small lab. It has serious money behind it, and the founder's resume is better than half of Silicon Valley. Meanwhile, Americans have been coping that, well, we're still ahead in some way or another. So precisely how is Kimi K3 winning here?
We don't just rely on a single agent, but we also orchestrate a swarm of agents that can accomplish the subtasks in parallel so that we can increase the task complexity. And we can translate all of this into the language of agents. So if you look at token efficiency, it's almost like magic that you get equivalently 100 trillion tokens. And nowadays, we are scaling towards the data war, and we're hitting the data war, and the amount of high quality data is quite limited. And if we suppose that is a constant amount, then we increase the token efficiency. It means that we're going to get better intelligence out of it. It's not just about infrastructure efficiency. It's about better intelligence. So this is why we spend a lot of efforts in this aspect, because it's going to push the frontier of intelligence. And Million Optimizer is one of the things that we have heavily invested in since last year.